what problem are you solving that no one else can solve? Don't be a commodity. Well, if you don't know what that is, you can't do anything for us.
Hi everyone, Charles here for LLM Papers. And today I'm not alone, I am with Arthur Gretton. So I already spoke a little bit about kernel methods on the channel, and they're one of the biggest tools in machine learning. Statistics always is very important. Statistical tests are also a big thing. And when you mention those fields to many people out there, one of the first names that comes to mind is Arthur Gretton. So needless to say here, we have again a huge rock star on the channel. Arthur Gretton, thank you so much for joining us today.
My pleasure.
For those of us who might not know you, would you please introduce yourself and your background?
Sure. So effectively, I began as an undergrad doing physics and signal processing, which are not perhaps traditionally machine learning topics. But I was always passionate about machine learning, even as a child. I loved robots, I loved AI, I read all of the Asimov books, as I think many of your readers, your listeners and audience have encountered as children. And so I always had the intention to explore machine learning and to move into that direction. When I began my PhD in a signal processing lab at Cambridge. But I had the good fortune to encounter Bernard Scholkoff, who was at Microsoft at the time, who then put me in touch with Rolf Herbrick, who was at Microsoft Research. And then we began work on machine learning. Bernard Scholkoff was one of the great pioneers of kernel methods, so that was giving me this context. Since then, I've continued to work in kernel methods, as well as expanding a little bit my interests to other fields like causality, diffusion models, and so on. But yeah, this is where I'm coming from. Yeah.
Could you talk to us a little bit more about your PhD topic and advisor?
Sure. So I was Rolf's first student. So I think the two of us were at a very similar age. But Rolf was a very sort of diligent researcher who liked to force me to wake up early. So I would have terrible late-night study habits, but Rolf would always insist that our meeting should be at 9 a.m. sharp at Microsoft. So I would have to, on those days, I'd wake up very early and I'd go to Microsoft, and then following our meeting, I'd sleep for the rest of the day. He was a very harsh taskmaster, but he got good study habits in me, so that was a plus. Initially, we worked on something called leave one out bounds. So these are methods to basically anticipate how well machine learning methods will generalize by computing approximations to the leave one out error, which is the error that you compute on a left out point when you train on the remaining points. This gives a pretty good sense of how well a method will apply on new data that it hasn't seen before. But obviously, training a method from scratch on n-1 points and testing on n points, that's expensive, so we approximated that. So this was quite interesting work, and this was a way that I guess learned a little bit about supervised learning, about generalization, and so on. Then I met at NeurIPS back in 2001, Alexander Smola, and he was very interested at the time in measures of dependence, in the context actually of the information bottleneck, which is a way of sort of compressing information while still retaining the predictivity of this compressed representation. And so I started working on methods for measuring dependence, and that became then its own thing and became, I guess, the genesis of a lot of the work that I subsequently did on hypothesis testing. Yeah.
What are you working on? What are your main topics?
One topic I've worked on for many years is hypothesis testing. So this is testing properties of distributions. So a classic example is I have two sets of objects, and my question is, are they from the same distribution or are they from different distributions? This problem of testing is a very rich one, and I've been working on that for many, many years. I continue to work on that in various areas. A second topic that I've been working on is the topic of generative modeling. And so, as you might guess, if you have a good measure of discrepancy between two sets of objects, you can use that as a loss function. So I'm trying to train a generative model to make images that match a target set of images. Then obviously having the experience of working on comparing distributions is a great foundation for training generative models using this as a loss. A third topic that I've been working on a little bit more recently is causal effect estimation. So this is basically what I'm interested in is I'm observing the world, and then I'm trying to learn the effect of acting on the world. So I observe an expert acting in some context, like a doctor acting in a medical context or a driver in a car. And then from that, I'm trying to work out, like if I got in the car and started driving, what would happen? And so, yeah, learning to act in context from observing the world is obviously a very current topic in machine learning, and this is one that I'm very interested in as well.
Is that somewhat related to reinforcement learning?
Absolutely. So causality and reinforcement learning, in my view, are two very, very intertwined disciplines. Reinforcement learning is learning to act in pursuit of reward. Causality is just trying to find out the effect of acting from having observed previous contexts. So it's quite interesting that both disciplines have developed the same tools with different names over many years in parallel, sort of parallel evolution. And so this is something that I'm exploring absolutely in my position at DeepMind, this connection between these two fields.
Would you describe your research and the various topics you described as more like theoretical or applied?
So I like to be at the intersection of application and theory. In particular, I found that without the connection to application, theorists can perhaps work on things that are more and more difficult to do and less interesting. So this sort of asymptotic behavior is something that is a risk for theorists. The work that I did on testing actually arose when I talked to neuroscientists in Tübingen. So I was a project scientist and then a research scientist at the Max Planck Institute in Tübingen. And I worked actually with a neuroscience lab there, which was headed by Nikos Logothetis, one of the great pioneers of neuroscience research. I had these measures of dependence and measures of difference in two sets of samples. And I came to the neuroscientists and said, hey, I've got this, would you like to use them? And they said, well, what's your p-value? And I was like, oh, p-value, what's that? And they were like, well, if you don't know what that is, you can't do anything for us. And so then I realized how important it was to take these measures and to determine whether they were significant or not. This is something that in machine learning, it hadn't occurred to me to think about. But it was this interaction with practitioners that gave me the impetus and the drive to start working on this area. In the same way, working at Google DeepMind, when I'm talking to people whose goal it is to interact with users, I get a really good sense of the problems they're trying to solve. And then this motivates the development of theory, which is grounded in practice. And I think this is the best kind of theory.
You said it's important to collaborate with people from other fields or other companies. So do you think it's like a huge plus for somebody in academia, for example, doing research to collaborate in like companies like Google DeepMind, for example?
No, absolutely. So I think that in modern machine learning, having a view and connection with companies is really essential because they're dealing now with scale, with data, with methods that academia at present just doesn't have access to. Not having a connection with companies really excludes you from a very large amount of the practice of modern machine learning, which, it's not to say that there's nothing you can do outside of a company, but it seems that you're, let's say, deliberately limiting yourself if you're ignoring such a huge part of modern machine learning. So yeah, to me, it's been enormously useful to be part of DeepMind, yeah.
Many people often compare neural networks to kernel methods, and they would say probably a bit hastily that kernel methods work less well than neural networks, so we should just focus on neural networks. What do you think about that, and what would you say to those people?
Sure. So my high-level recommendation is use what works. So depending on the setting, kernel methods or neural nets are the suitable tools. So use the tool for the job. I like, in a sense, Kaggle as a venue because this is where reality check hits. Like whatever method works is the one that you use. Going back, let's say, to kernels versus neural nets, if your data are very structured, you need to extract learned features from that data, then neural nets are the way to go, absolutely. If you have, let's say, limited data and you have functions that are sort of generically smooth, and this is something we found, for instance, in our work in econometrics, then it seems that kernel methods are actually good because they're very data efficient. They make sort of general purpose smoothness assumptions on the functions, and then they learn under those assumptions. So if your data are limited and relatively low dimensional, then these methods are perhaps the methods to use. I would also say that in certain circumstances, you're able to obtain strong guarantees using kernel methods, which are harder to obtain in neural nets. And for example, I think one topic where kernel methods are still very widely used is in hypothesis testing, where you're wanting to guarantee that your tests are consistent, which is to say, as you see more samples, your false positive rate is going to stay fixed at the design parameter and your false negative rate is going to go to 0. These are guarantees that you can be certain of for kernel methods. But if you're using perhaps a neural net measure of discrepancy between sets, it might be harder to enforce those guarantees. So depending on your application, you might, if you're doing drug design, for example, you might be very intent on having those guarantees hold. I would say finally that in bioinformatics, for example, users have spent a lot of time designing kernels for particular applications. So kernel is just a measure of similarity between objects. And if you have a lot of domain knowledge, you can design a measure of similarity which is really good for the domain that you care about. So I believe that there are still domains in biology, for example, where kernels remain very valid because experts have spent a lot of time designing good kernels for the problem at hand. So in summary, use what works. Whatever works is what you should use. Yeah.
The truth is the results in the applications, and no matter what people say, what works counts. And if in practice, for some problems, kernel methods work better, they are the ones to go with.
Yeah. I will say as well, like in my own modern work, I've been pretty much using everything. I've used sort of hybrids of kernels and neural nets depending on the circumstance. I've had models that are purely neural net based. I've had models that are purely kernel based. I've had models in between. For me, I'm just a pragmatist. I just use whatever works for whatever data I've got. Yeah.
Now I would like to touch a different topic. You have various positions. You are a professor at the Gatsby Computational Neuroscience Unit. Sorry, I have to check because there's many of them. You're also director of the Center for Computational Statistics and Machine Learning at UCL, University College London. And you're a research scientist at Google DeepMind. How do you handle all that?
With difficulty, so it's a lot of work. So the CSML is a cross-faculty organization which is part of the European-wide LS unit for machine learning. And this is a sort of cross-faculty organization incorporating machine learning research in statistics, in computer science, in electrical engineering. Basically, wherever there are people at UCL with a machine learning focus, we're trying to sort of bring them together and have a common organization for them, and workshops, talks, and so on, common to all of these individuals. One of the things that we did as part of that was the Machine Learning Summer School in 2019, which was, I think, really enjoyable. And I continue to meet students who've attended that in machine learning conferences. It's always a pleasure to see like how they've gone. Then obviously I have my research group at Gatsby, which tends to be a little perhaps more theory focused. Then at DeepMind, obviously I've been there just for a year. I went there initially on sabbatical. I'm going to continue working there for the coming month, and then we'll see how things go. But yeah, there my work has been a little bit more applied, so I've been interacting more with some product people, as well as obviously with people working on distributional RL and other topics that are well, I guess, correlated with my work on causality.
I see. And what does your day look like? Like, how much time do you dedicate to research, reading research papers, supervising students, doing administrative stuff, and more, and networking?
So 110% for all of those things. No, it's yeah. But I would say Gatsby is very unusual in that the amount of administration is relatively low in respect of normal university departments. So it's funded by a charitable foundation, which David Sainsbury set up. So we have relatively little teaching, we have relatively little administration, and we have the privilege of being able to focus on research. And I'm very grateful to have this. That, I think, has given me the opportunity to focus much more on research during my time at Gatsby than might normally be the case in a university department. Nonetheless, because of the CSML work, there is a certain amount of administration that is unavoidable. And at DeepMind as well, there is a certain amount of administration that's unavoidable. So I try to sort of reconcile those responsibilities with as much time spent on research as I can. I will say that for paper deadlines, I've still been known to stay up until 3 with students doing the final push on papers. So that's something that even now I'm occasionally prone to doing, but yeah, I enjoy that very much. Yeah.
It's something important I would like to mention about UCL is that entrepreneurship seems to be a huge thing there. Demis Hassabis and Shane Legg are two of the co-founders of DeepMind, later acquired by Google, and they came from UCL, but also from the Gatsby Computational Neuroscience Unit. So I would like to ask you if that is frequent that many students launch their own business.
I think that Shane, Demis, and Mustafa were really quite exceptional. I would say that the case of DeepMind is a relatively unusual one. I would certainly be happy, obviously, if any of my students were to take the entrepreneurial route. Certainly, many of my group has gone on to work at Google DeepMind, particularly, former students are presently there. But I would say that Gatsby, I think, has produced many members of faculty and I guess employees of research labs of large companies. But I would say DeepMind is really an unusual situation.
then Google DeepMind has like some historical connection with Gatsby. Can students from there actually benefit from, for example, research collaborations with DeepMind people?
Absolutely. So many Gatsby students to this day have ongoing collaborations with members of DeepMind. So several of my group have worked with several members of DeepMind. We've published a number of papers together. I think it's fantastic, like to have in London such a huge community of really top researchers. It's extremely unusual for any city worldwide. And this is something that I think my students have benefited from very much, as well as other students at Gatsby. There are also members of DeepMind who are research engineers there who actually do PhDs at UCL. And so they remain employed by DeepMind, but they're supervised in doing pure research at UCL. I've had the good fortune of working with several of these students, so Yajay Lee and Alexandra Galashov. So this is, again, like a wonderful occasion to interact with people at DeepMind and to explore the kinds of topics that might be very hard to work on purely in academia.
As a final word for some of our viewers, I know that some of us have or had been or will be at some point in their life interested in the option of launching their own business, especially related to the field of AI, which is one of the most prominent ones in nowadays work scenes. For all those people, what advice would you give?
I'm going to risk perhaps sounding a bit like a fogey, but the current boom in AI has a little bit of a feeling of the .com boom in the early 2000s. So at that time, everyone had a startup, everyone had an e-commerce site, and you had yourpets.com and all of these things. And at some point, there wasn't sort of very much to differentiate or make unique these various businesses. And at some point, the funding ran out, and they all went bust. So I feel that at the moment we're seeing something very similar. We've got many startups that have LLMs, and all of them are saying, well, we've got an LLM, but we're different to the other 500 LLM companies that are out there. I feel that just like an e-commerce website, these language model-based startups, like this is a technology that will become commoditized. It's not a differentiator. What differentiates you is that you have a product that is unique, that you have a niche where you're solving somebody's problem that no one else can solve. An example being something like AI for chip design. You're actually solving a problem that no one else can solve. You're doing something useful. So I would say if you're doing a startup, like what problem are you solving that no one else can solve? Don't be a commodity, don't be just another LLM startup, but do something really unique and have focus on your customer base and who it is that you're trying to serve.
So again, kind of connected to what Arthur said in the beginning, relate to the application, how useful is that going to be? And I think that will be like the key message from what you have said today.
Yeah, absolutely.
Arthur, thank you so much for joining today.
My pleasure.
That was a great pleasure to have you on the channel, and thank you so much for watching this interview and making this channel alive. If you enjoyed this new type of format interview, well, not so new on the channel actually, well, don't forget to give it a thumbs up, subscribe, hit the bell icon to get notified of the next video. We'll upload new content every week or almost every week, so stay tuned. Thank you so much for watching. I wish you a wonderful week, and I'll see you in the next video. Cheers.